How to read Honda wiring diagrams. This program is the second in a series of full-cycle film strips on electrical troubleshooting for motorcycles.
Wiring diagrams are like a roadmap to accurate electrical troubleshooting. They help you get the job done right, because you don't have to guess where the wires on a motorcycle go. And done quickly, because you can pinpoint areas you need to test. So this program's going to help you learn how to read the Honda wiring diagrams.
Here's our specific objectives. At the conclusion of this program, you should be able to identify electrical components and symbols on the Honda wiring diagrams. Second, you should be able to describe the function of wire colors used on Honda motorcycles. And third, you should be able to trace a complete electrical circuit from the load to the power source. Incidentally, we assume you understand electrical fundamentals. Fundamentals like those shown in the first program in this series, the basics of electrical troubleshooting. If you're not familiar with electrical circuits, failures, and troubleshooting, watch that program before continuing with this one.
Now, the wiring diagram shows every circuit on the bike. But in troubleshooting, you usually just be tracing one single circuit.
Actually, the individual circuits are pretty simple. For example, here's the ignition circuit for the 1980 CB750K. Nothing too complicated, just pulse generators, spark units, ignition coils, spark plugs, and of course, an ignition switch. Adding the charging circuit causes the wiring diagram to begin to take shape. An alternator and a regulator rectifier are the main components of the system. Here's the headlight circuit, a fuse, a switch, a headlight assembly, and more wires, more lines to trace on the diagram. And the starter circuit, with starter motor, starter relay switch, and starter switch. And the various instruments, warning lights, and so on, to complete the entire wiring diagram. Understanding that the diagram shows many individual circuits is important in troubleshooting, because it's individual circuits that you'll have to identify and trace on the diagram.
So think in terms of isolating the circuit you're troubleshooting. Focus your attention on just one circuit at a time, and you'll find that it's a lot easier to understand.
All right, let's take a look at the basic layout and symbols used on Honda wiring diagrams. First, understand that the diagram does not show the actual location or relative size relationship of wiring components. It's a simplified representation of the motorcycle wiring and components.
But the diagram does show every wire in the harness, with its color coding. That BRW here means brown with white tracer.
When you see wires on the diagram joined by a dot, that means they're physically connected together in the harness. However, if wires cross with no dot, they are not physically connected. The wires are simply crossing over on the diagram. Most circuit connections are made with connectors like the ones you see here. You'll find plug connectors that carry several wires and individual connectors that connect one or two wires together.
On most Honda wiring diagrams, the headlight, front turn signals, and instrument lights are on the left side. The tail light and brake light and the rear turn signals are on the right. Now, the precise location of other components varies from diagram to diagram, so you'll just have to keep a close eye on the diagram.
Most components are clearly labeled, and you'll have little problem in locating whatever you're interested in. You can count on the labels to help you.
Also, instead of electrical symbols everywhere, the diagrams use pictorial drawings to represent most of the components, and that helps make them easy to spot.
But a few electrical symbols are used on the Honda wiring diagrams. One of the more common is chassis ground. Whenever you see it, you will know the circuit is directly connected to ground. And notice here the ground wire is green. In fact, on all Honda motorcycles, ground wires are always green.
And this is a symbol for a coil. It can represent a coil in the alternator or in the pulse generator of TPI-equipped motorcycles. Also, you'll find it in ignition coils and in a starter relay switch. Fuses are sometimes represented by the symbol on the left, but more commonly, you'll find a drawing like on the right to represent fuses on Honda wiring diagrams.
Another common symbol you'll see is for a diode. Now, a diode, as you may know, lets current flow in only one direction through a circuit. You'll commonly find diodes in the rectifier and in the starter safety circuit.
Lights are represented pictorially on all Honda wiring diagrams. The drawing style varies a bit from diagram to diagram, but they're always easy to spot.
Now that you've seen the layout and symbols used on the Honda wiring diagrams, let's look next at wire color codes and their meaning. This is how you follow the correct path, how you relate the diagram to the motorcycle. To help you, every Honda wiring diagram has an index of wire color codes, colors that match those on the motorcycle. The color codes do differ for different model and year bikes, so be sure to look at the index every time you use a wiring diagram. Each wire is color-coded at the connectors and the components. For example, here at the connector between the alternator and regulator rectifier, you see yellow wires, a black wire, and a white wire. Notice the wire color does not change through this connector. The wiring diagram shows exactly what you'll find on the harness.
However, on some connectors, wire colors do change from one side of the connector to the other. For example, here you see a yellow wire that connects to a white wire on the other side of the connector. Always pay close attention to which side of the connector you're working on. You'll find small colored tubes or bands on wires where wire color changes take place through a connector. For example, here's a white tube on a yellow wire. This tells you that the current path continues from the yellow wire to a white wire on the other side of the connector. It's a really nice feature of Honda's wiring harness. Wire colors are used consistently on most Honda models. In other words, a circuit with a particular color on one Honda will usually have the same color on another. For instance, here you see the yellow wires in the charging system circuit of 4 different Honda motorcycles. On any battery-equipped Honda motorcycle, the red wire is the hot lead from the battery to the ignition switch. There are no other circuits on the bike with a red color code except this circuit. Also, a black wire is always the hot lead from the ignition switch to the individual circuits or the fuse box. So when you're at an ignition switch, you know exactly where the black wire goes on any Honda motorcycle. As we mentioned earlier, a green wire on any Honda motorcycle is the ground wire for its associated circuit. Green is always ground.
This wire color key lists 23 wire colors that are used consistently on all Honda motorcycles. The chart gives you the usage of each wire and tells you from where to where each wire goes. You can order copies from American Honda, reorder number S1149. A useful feature on the diagrams is the switch continuity tables. The tables show you how current flows through a switch in each switch position. Let me show you how to use them. Here's the continuity table and ignition switch for our CB750K. Notice that the switch terminals are shown across the top of the table. These, of course, correspond to the terminals of the ignition switch: BAT1, IG, PA, TL2, and TL1. Notice, too, that the ignition switch terminals connect to certain wire colors. The continuity table tells you which terminal to go to, but you have to look at the diagram to determine the associated wire color. In the left column, all the switch positions are shown: off, on, and P, which stands for emergency park. Notice that in the off position, no current flows, so all the terminal spaces are left blank. In the on position, the table shows that the BAT1 terminal and IG terminal are connected, and current will flow between them. Also in the on position, the TL1 and TL2 terminals are connected, and current will flow between them as well. By the way, all electrical circuits on the bike can function with this switch in the on position. With the ignition switch in emergency park, or P position, terminals BAT1 and P are connected. This allows current to flow from the red wire through the ignition switch to the brown wire, which carries current to the motorcycle taillight. Here's the continuity table for the starter switch. Again, the terminal descriptions for the switch run across the top of the table, and the left column indicates the switch positions. In this case, free and push or start. In its free or unpushed mode, the terminals BAT5 and HL are connected. By the way, HL stands for headlight. Therefore, the headlight receives battery current whenever the ignition switch is on and the starter switch is free. But when the starter switch is pushed, current to the headlight is broken, and the terminals BAT2 and ST are connected so that battery current flows to the starter. This ensures that the starter can get all the current available to start the engine.